Welcome back to the Interaction System series. In episode 4, we're going to be taking our interaction system to the next level by adding a door interaction actor. In previous episodes, we built the framework for handling multiple interactables and even refined the active selection with dot product calculations. Now we'll create a door that the player can open and close, and that will integrate seamlessly into our system. The episode itself will walk you through building the door actor, implementing its unique interaction logic, and testing it in your game world. So let's dive in and add doors to our interaction system. As you can see, we're back in the template project where we've been building our interaction system for this entire series. The first step for this episode is to create a new blueprint for our door actor. So just navigate to the interaction system directory and then the interactables folder within that. Then you can just right click inside the folder and select blueprint actor and name it BP_door. And then just open up that blueprint. And the first thing we want to do is start adding our static meshes. So click the add button and search for static mesh, and then add it and rename the first one to door frame. In the details panel on the right, click the static mesh dropdown and search for SM_door frame from the Unreal Engine starter content. Next, we need to add a static mesh for the door itself. So click add, search for static mesh, and add a new static mesh component. And then in the details panel, this time we're going to search for SM_door. And then just adjust the position of the door so that it fits perfectly in the frame. And then let's just come back over to the left and rename that static mesh to door. And now it's time to integrate our interactable component into this new door actor. So just like when we added the meshes, click add and search for BP_interactable, and then add that to our door. This adds our interactable functionality to the actor. And now we need to make sure the actor implements our interface. So click on class settings, and on the right hand side, navigate to the implemented interfaces section, and then search for BPI_interactable on that list. And with these steps complete, we're now able to start actually implementing the interface and giving this door some behavior. And now that our door actor implements the interface, we can simply navigate to the left panel under interfaces, and you should see the interact function available. Double click it to add it to the event graph. And remember in the last video when we talked about blueprint interfaces? Well, this is where they kind of shine. By implementing the interface function, we can give each object its own unique behavior while keeping our interaction system decoupled. There'll be no need for spaghetti code or any kind of weird branching structures to try and determine what type of object we're dealing with in our interaction system. And it's pretty common that the first thing we would want to do when we go to interact with a door is to determine whether the door is currently open or closed. And to track that, we can add a boolean variable in the left panel and name it isOpen. Then just drag that variable into the event graph. The isOpen variable will serve as a flag to decide whether the door should open or close when interacted with. With that in place, we're ready to implement the door's specific interaction logic. So let's move on and start wiring that up. The first step to that is to invert the current value of the isOpen variable. And to do this, we can simply drag out from that isOpen variable in the graph and add a not boolean node. This node will take the current value and return the opposite boolean value. And next we need to update the isOpen value to this new value before any further logic is executed. So simply drag a setter for the isOpen variable into the graph and then connect the execution flow from the interact event to that setter. Then you can connect the output of the not node to the isOpen pin on the setter node. Now that we've toggled the isOpen status of the door, our door will actually still remain in its original position in the game world. So it's time to animate it so that it actually opens or closes. Now, the next thing we want to do then is add the isOpen value again to the graph and connect it to a branch node. And this will let us conditionally execute logic based on whether the door should open when the isOpen value is true, or close when it is false, remembering that it is currently the opposite of whatever it is in the actual game world. And now we can just drag out from that true pin on the branch node, which represents the door being in the open state, and add a timeline node. Rename this timeline to something descriptive like door open or door open/close or something. The timeline node allows you to create and control animated behaviors over a specified duration. Essentially, you can define curves, whether for movement, rotation, color changes, whatever, and play them back over time to update the values smoothly. This makes it ideal for achieving a smooth door opening transition. And now you can just drag from the false pin on the branch node to the reverse pin on the timeline. This essentially just says to play the animation in one direction if we are opening the door and playing it in reverse if we're closing the door. Now, we'll actually come back to this node in a moment to set the animation up, but for now, let's just finish out this set of nodes to get the main functionality working. With the timeline in place, it's time to hook the door mesh up so that we can animate it. Grab the door mesh from the components panel on the left and add it to the graph, and then drag out from it and add a set relative rotation node. And then you can just connect the update execution flow pin from the timeline node to the execution input on your set relative rotation node. This means that every update of the timeline, the door's rotation will be updated accordingly. And now we want to configure that rotation for yaw. So we want to rotate the door around the z-axis or the yaw. So right click on the new rotation input pin of the set relative rotation node and select split struct pin. This splits the rotation into its individual components, pitch, yaw, and roll, so we can focus on modifying only the yaw value. And now that we've split those up, we're almost ready to hook it all up to our timeline's output to drive the door's yaw. But first, let's actually go back and set up that animation I was just talking about earlier so that we can have that curve move through the timeline and rotate the door correctly. Double click on the timeline node to open its dedicated timeline editor window where we can set up the animation curve for your door. And in here, the first thing we want to do is click add track and then add a float track. Name this track something sensible like door open. And set the track's length to 1 second. And now it's time to actually set up the keys for the animation. So right click on the timeline graph and choose add key. And then for that key, you can set the time and value both to be 0.0. And now we want to add another one the exact same way. So right click on the graph and add a new key, but this time set the time and value to both be 1.0. And then just to smooth out the curve and make the animation a little more realistic, let's right click on the first key and change its key interpolation to auto. This auto interpolation creates a smooth, curved transition instead of a harsh linear change. In the timeline, you'll notice a nice smooth curve instead of the previous sharp 45-degree angle. And then compile, save, and head back on over to the event graph. The timeline now controls the door's rotation animation, allowing for a smooth transition when the door opens or closes, but it's not actually hooked up yet, so let's finish that bit out. You'll notice that our door open curve appears as a pin on the timeline node now, so simply drag out from that pin and add a multiply node. Set the multiplier value to 90 because we want the timeline's output to control a 90-degree rotation of the door. Next, take the output of that multiply node and connect it to the yaw input on our set relative rotation node. This connection means that as a timeline progresses, the door will smoothly rotate by 90 degrees, creating a natural opening motion. That's it for this part. Our timeline is now directly driving the door's yaw rotation based on the animation curve. So let's take a moment to quickly look back over this function and see what it's actually doing. First, when the player interacts with the door, our overridden interact method from BPI_interactable is triggered. Inside this method, we'll immediately flip the door's current isOpen boolean, toggling it from true to false or vice versa. Then, based on the new value of isOpen, we play our animation timeline in the appropriate direction, opening or closing the door. As the timeline runs, its output, scaled by 90 degrees, continuously updates the door mesh's relative rotation on the yaw axis. This creates a smooth, animated transition that either opens or closes the door, depending on the interaction. And now we're actually ready to test this, so let's compile, save, and head back to the main editor, and then just drag an instance of our door out into the play area, and then hit play. And now if you just run up to the door, you'll see that little E interaction widget. Just hit the E key, the door will open, hit it again, it'll close. You can keep doing it over and over again. And that's really our first interactable object that works with our system in this series. Stay tuned for the future episodes where we start to build out other types of interactable objects. In the meantime, if you have any questions, put them in the comments. Don't forget to like this video and subscribe to the channel if you want to get future video updates. That's it for now, and I'll catch you in the next one.